Hello everyone and welcome back to another of my videos. Professional CCTV systems can cost enormous sums of money, so in this video I'm going to show you how to make a low cost, effective, highly customizable and open source system based on a Raspberry Pi. Before we get into this video, make sure you check out my other videos which are here somewhere to help me grow my channel as quickly as possible. Anyway, on to the video. At the heart of this build will be the MotionEyeOS for SBCs, or single board computers, developed by Kristen on GitHub. It is a phenomenal piece of software as it is so versatile and has so many great features which I'm going to use in this project. To run the software you will of course need a Raspberry Pi. It doesn't matter which version, however if you aren't using the Raspberry Pi 3 or 0W then you will need an additional Wi-Fi dongle. For my setup I'm using a Raspberry Pi 3 and 2B for the cameras and an original Raspberry Pi for the server. However, I'll explain how this is going to work in the next episode. As for the cameras, I recommend the Pi No IR as it gives you night vision capabilities if used with infrared LEDs. However, the regular Pi camera or any ordinary webcam will work just fine. To download the operating system, head over to the GitHub page linked in the description and select the version that matches the Pi you are using. I downloaded all three as I was going to use the Raspberry Pi 1, 2 and 3. In order to create a bootable microSD card, you will need to download some software called Etcher, which is free to use and is great for creating all sorts of bootable disks, just not for Windows, but this is Linux so it will be fine. If you're using a Mac, like me, then you can just use the disk utility to erase it as FAT and then you're good to go for the next step. If you're using Windows, then download another great tool called Win32 Disk Imager and use that to erase the card. There are literally hundreds of videos showing you how to do this. Now onto Etcher. Simply select the image that was downloaded from GitHub, select the card and then finally click Flash. Done! The next few steps are the same with any Raspberry Pi project, so push the microSD card into the slot, connect an Ethernet cable to access it via the network and plug it into the power. The red light should come on and the green light should begin to blink, which means it's starting up. If the green light remains on and doesn't flash, it means the Pi can't boot, so you need to re-image the card, making sure you have the right version. If you don't have Raspberry Pi 3 or Pi 0W, then you'll need to connect a Wi-Fi dongle as well and then enable it in settings. More on that later. To find out the IP address of the Raspberry Pi, which is needed to connect to it, you will need to perform a scan of your network to find out what it is. For Mac, there is a great tool called LANscan, which can be found in the App Store. Simply make sure your Pi is powered on, give it a few minutes to start up, and then click the play button to start the scan. A device with the Raspberry Pi Foundation vendor should show up, and next to it is the IP address. For Windows, the same principle applies, but the software is called Angry IP Scanner. Grrr. In order to view the user interface and live stream, open up any browser and type in http:// followed by the IP address of the Pi as shown and press enter. After a few seconds a dialog should show up asking for a username and password. The default username is admin and the password is left blank. This can be changed later for better security. Once you have entered the login details, you'll see the live camera feed. It'll probably look super laggy, so click on the bars in the top left hand corner, which is where the settings panel is, and enable advanced settings. Under video device, drag the frame rate slider from 2 FPS, which is the default, to whatever you like. 20 FPS is a good number as it gives you enough clarity without taking up too much storage. Make sure to click Apply after you change any settings. In the Settings tab, we can also set up motion detection that records video and takes a picture every time something moves in the frame. Near the bottom is a conveniently labelled tab called Motion Detection. Surprise, surprise. Under it is another slider that controls the threshold of how much the frame needs to change in order for the system to be triggered. The lower the number, the more sensitive the detection will be, so it will pick up people and cars with ease, but may also be triggered by moving trees or even changes in light levels. Of course, a higher number therefore means less sensitivity, but potentially more accurate detections. I've set mine to about 2% as that's what works best for me. Have a play around. Whilst this will enable the recording of motion videos, you can also set it up so that it will take pictures when motion is detected. This can be used as a snapshot to see what triggered the motion detection, rather than having to watch all the footage. Seriously, it's not just me being lazy. In addition to motion detection, there are also settings to change where the files are stored, for example on a network location. It's supposed to be really simple, so just click the storage device drop-down menu and select network location, and enter in the IP address, call it something, fill in the root directory and press apply and boom! Oh, wait, I get an error message which I can't get rid of. If anyone knows what I'm doing wrong with the Pi, then please leave it in the comments below. Okay, so some settings that actually work are basically everything else apart from this. For example, setting up a streaming port to getting emails when motion's detected. As I mentioned at the beginning of the video, it is also a good idea to change the default password to something less guessable than nothing, and perhaps edit the host name so you can identify easily on your browser or network. Talking about networks, setting up Wi-Fi is super easy providing you have your router's SSID and password, which are on the back. Under Network, enable wireless networks and then enter the SSID into the network name box and the password into the password box. If you want a more advanced configuration, then you can also set up a static IP address. So, thanks for at least skipping to the end of the video to watch this amazing outro. Keep a lookout for the next video in this series where I'm going to be networking the cameras together and creating a central hub to keep watch of all your cameras. You know what else you need to keep a watch out for? That subscribe button, so hit the subscribe button, like this video and comment down below if you've got any future project suggestions. Anyway, thanks for watching and I'll see you in my next video.